We are going to look at common factors. We're looking at whole numbers and we want to talk about common factors between numbers. Let's look at this example here. It says write down all the factors of 15, 30, and 45. It's just listing down the factors of 15, 30, and 45. So the factors of 15 are 1, 3, 5, and 15. The factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. And the factors of 45 are 1, 3, 5, 9, 15, and 45. So that is the first thing we need to know. We need to know factors, like all factors of a given number. The second thing I want us to do is from that list, I want us to write down the common factors. Right, so which of those factors are common? So I want common factors of 15, 30, and 45. Just common factors. It's just a matter of looking and comparing them. So we agree our common factors, 1 is common, you'll see that. So 1 is common. Right, what else is common there? It has to be common in all of them. Let me do this. So 1 is common, and 5 is common. Oh yes, there's 3 as well. 3 is common. Anything else that is common? Yes, 15 is common. There's 15 here, there's 15 there, and there's 15 there. So we can then write down the common factors. These are 1, 3, 5, and 15. So these are the common factors of these 3 numbers. Now the third thing is we can now determine the highest common factor. Right, the highest common factor is definitely 15. So you will get questions that require you to determine the highest common factor of a given set of numbers. You can use this method, maybe just to go through this again. So if you want the highest common factor of 15, 30, and 15, the first thing could be for you to write down all the factors of the numbers. Then obviously write down the common factors of the numbers. And then from the set of the common factors, you can determine the highest common factor. I want to show you another method, which is the method of prime factorization, which I believe is shorter than this method. Instead of doing all this, you can just use factorization, prime factorization. Let me show you how you can answer the same question using prime factorization. Okay, so we want the highest common factor, which is abbreviated as HCF, of 15, 30, and 45. So we will prime factorize, that is the first method, prime factorize each of the numbers. So we prime factorize 15 here. Let's put 30 here. And let's put 45 here. We need to prime factorize this. 3 will go into 15 5 times. And 5 goes once. Remember, you can use the ladder method if you think the number is too big. Otherwise, we all know 15 is 3 times 5. So we could have just returned 15 as well to 3 times 5. There's no need for the ladder for small numbers. 30 would be 2 into 30 will give us 15. Then 3 into 15 will give us 5. Then 5 into 5 will give us 1. This is also a fairly small number. For 15, divide by 3 first. You should get 15. Then divide by 3 again. That will give us 5. Then divide by 5, and that gives us 1. So 15 is 3 multiplied by 5. 30 is 2 multiplied by 3 multiplied by 5. And 45 is 3 multiplied by 3 multiplied by 5. Okay, so we prime factorize our numbers first. Now we are looking for the highest common factor. And now to get the highest common factor, you need to compare those prime factors and pick everything that is common. Like we have 3 here, we have 3 here, we have 3 there, so 3 is common. And so we will put down a 3 because 3 is common. You will notice also that there is a 5 there and a 5 there and a 5 there, so 5 is common. So we need to multiply that by 5. Then the answer then becomes 3 times 5, which is equal to 15. So the highest common factor is equal to 15. Try using this method. You will agree with me this could be short. Here is another example. Find the highest common factor of the following numbers, and you can leave your answer in exponent form. So we are given 3 numbers here. These numbers have been prime factorized already. That is why the first number there is just 2 cubed times 3 to the power of 4 multiplied by 5 to the power of 2. So it's a number that has been prime factorized already for us. The second number is 2 squared times 3 cubed times 5 cubed, already prime factorized for us. And the last one is 2 multiplied by 3 squared multiplied by 5 squared, also already prime factorized for us. These look like big numbers, large numbers indeed. Right, because they've been factorized already, it actually means we can just go on and work out the highest common factor using the same method that we discussed. So what you do is you need to look for what is common in all the 3 numbers. So what is common in all the 3 numbers? Let's start with 2's. In the first one, there is 2 cubed. In the second one, there is 2 squared. In the third one, there is a 2. Right, so what is common? Obviously, 2 is common. So we need to take that 2. It is common. There is a 2 here, there is a 2 there, there is a 2 there. Please understand why 2 is the common factor there. There's only a single 2 that is common in all of them. Now, what about the 3's now? The first one has 3 to the power of 4. The second one is 3 cubed, and the third one is 3 squared. So what's found in all of the 3? Obviously, that will be 3 squared, because in the third number, we do get 3 squared. In the second number, there is a 3 squared as well, because that is 3 cubed. Now, 3 to the power of 4 obviously means 3 squared is there already as well. So you will understand then that 3 squared is common. Then we move on to the 5's. That is 5 squared, that is 5 cubed, that is 5 squared. So what's common in all the 3? I think it's 5 squared, right? And yeah, the question says leave your answer in exponent form, so we can just leave our answer like that. But obviously, if we want, if you think this is a small number, you can just multiply out, because this is actually 2 multiplied by 9 multiplied by 25. So you can multiply out and get a number, but for very large numbers, we will just leave our answers in exponent form. So this is our answer in exponent form. Please try as many questions as possible that look like these 2 examples that I've shown you.